Alright guys, in this video we're going to talk about balancing redox reaction in acidic and basic conditions. So in a previous session we learned about redox reactions, oxidations, and reductions. In this particular session we'll learn about how to balance a given redox reaction. Now you can balance redox reactions under acidic conditions and under basic conditions. So we'll learn first in acidic conditions, then there is only one more step to turn a balanced acidic redox reaction into a basic condition. Now, when it comes to balancing the equations, you want to make sure you have your masses conserved. Another way of saying you must have the same number of atoms on each side, and that also applies to the charges. You must have the charges conserved as you're going from the reactants to the products. So when you're separating the half reactions, I'll separate the lead with the lead. Okay, so that's your one half, and your other half is going to be the one with iodine. Okay, so if you see an oxygen and a hydrogen in addition to two other elements, then ignore those. Okay, so you're only focusing on the atoms that are not hydrogens or oxygens in the beginning. Well, now there are going to be times when you only have hydrogens and oxygen. Then it's a different story. Then you have to separate those half reactions based on the hydrogens and oxygens. But if you have two other types of elements, then separate your half reactions based on that. So when I separate those, okay, this becomes IO3 1 minus, and that goes on to make I2. And then the other one is going to be the PB2 plus, and that goes on to make PbO2. So those are half reactions, and when it comes to figuring out what's the oxidation and what's the reduction, you don't want to worry about that yet. You will know once you balance those which one is the oxidation and which one is the reduction. So once you have done so, the next step is going to be balancing their atoms. Okay, so you always want to start balancing the non-hydrogen and oxygen atoms. In this case, we have iodines on both sides, so you want to make sure you balance the iodines first. So to balance out the iodine, I would have to go ahead and put 2 here in front of the IO3 1 minus, so that will take care of the iodines. Now, then you want to count how many oxygens you have. So in this case, you have 6 oxygens on the reactant side. So to make sure I have 6 oxygens on the product side, I would balance the oxygens by adding the water molecules on an appropriate side. So I want to go ahead and add 6 water molecules on the product side. So in doing so, we have 12 hydrogens on the product side now, so we've got to make sure we balance the hydrogens as well. And the hydrogens are balanced by adding the protons, or H plus, on the appropriate side. So in this case, the 12 hydrogens must be added on the reactant side. Okay, so seems like this is going to be a balanced equation, and you want to make sure you go back and double check. So we have 12 hydrogens, we have 2 iodines, and we got 6 oxygens on both sides. So it's balanced in terms of the mass. Now you want to balance the charges as well. Okay, so the total charge you have on the reactant side, we got 12 pluses here. Okay, so I can write down 12 pluses there, and I got 2 minuses there. So that's a total of 10 plus. So I must have, let's see what we got on the product side. There's no charge on the product side. So you should not have any charge on either side. So to make sure I take care of that extra 10 plus charge, I would have to add 10 electrons on the reactant side. Okay, so once I added these 10 electrons on the reactant side, this reaction is balanced. Now let's focus on the second one. So we got this lead. Let's copy that down here. So this lead 2 plus makes PbO2. Lead is already balanced. We have got one lead on each side, so you don't have to worry about balancing the lead. Let's look at the oxygen now. So we got 2 oxygens on the product side, so I can go back and add 2 water molecules on the reactant side. In doing so, I have 4 hydrogens on the reactant side, so I gotta go and add 4 hydrogen pluses on the product side. Okay, now let's look at the charges. we have a 2 plus charge on the reactant side because the lead 2 plus is the only one that's giving you the charge. And on the product side, you got 4 plus charge. Okay, so that means I can go ahead and add 2 electrons here, and that will take care of all the charges as well. So now you got an overall of 2 plus 2 charge here, and that's what you really have on the reactant side as well. Okay, so this reaction is also balanced now. Now, like I said earlier, you didn't have to worry about what is the oxidation half cell and what's the reduction half cell, but now you can easily figure it out by looking at the electrons. Now, in the first reaction, we are adding 10 electrons, and in the second reaction, we're losing 2 electrons. So if you recall, the reaction that actually have the electrons added is going to be the reduction, because remember, the reduction is the addition of electrons or the gain of electrons. And the second one, that where you're losing the electrons, it's going to be your oxidation half cell. So that's how you figure out which one is the oxidation half cell and which one is the reduction half cell. Okay. Now we're done with balancing the charges by adding electrons. Okay, now we gotta make sure both of these half reactions has the same number of electrons. What that means, if I go back onto the reduction half cell, I got 10 electrons being added. On the oxidation half cell, I got only 2 electrons being added, 2 electrons being removed rather. So that means I need to make sure both of those are the same. And sometimes to make sure they're the same, you multiply those by one another. But in this case, to make oxidation to be losing 10 electrons, I can multiply this oxidation half cell by 10. Okay, so when I do so, nothing else changes on the reduction side, so I'm still going to have 12 protons plus 2 IO3, 1 minus, plus 10 electrons, and that goes on to make I2 plus 6 water molecule. Okay, so that's your reduction half cell, and in the oxidation half cell, since you're multiplying by 5, okay, so that's going to be 10 water molecules, and you got 5 Pb2 plus, and that goes on to make 5 PbO2 plus 20 H pluses, and we have 10 electrons. All right, so you gotta make sure you have your charges, your electrons to be the same on both of those half reactions. Okay, so once you do that, you want to make sure now you add your half cells. That's going to be your last step, adding up the half cells. So when you add these two reactions up, let's see what we come out to be. And you want to see what cancels out on each side. So I can see, okay, I got this 12 protons on the first reaction, and I got 20 protons on the second reaction on the product side. Now, since they are on the opposite side, I can get rid of these 12 protons, and 20 protons will leave you with only 8 protons overall. When I look at the electrons, I got 10 electrons being gained and 10 electrons being lost in those reactions, so they will also cancel out. So those 10 electrons goes away. What else is common? We can see there is a water. We got 10 water on the reactant side for this in the second reaction, and we got 6 water on the product side on the first reaction. So those 6 will cancel out the 10, leaving with 4 water molecules overall. So you just copy down your reactants, you can copy down your products, and that will give you the net reaction. Okay, so then we have 4 water molecule. We got 2 IO3, 1 minus. We have 5 Pb2 plus. Okay, so those are your reactants. There's really nothing else on the reactants we have. Okay, on the product side, we have I2. Okay, we got 5 PbO2 and then 8 H pluses. So that's going to be it on all those reactants and products, and you want to go back and make sure everything is balanced again. So we got 2 iodines on both sides. Okay, so that's good. We got 5 leads on both sides, so that's good. How many hydrogens we got? Let's see, we got 8 hydrogens on the product side, and we have 8 hydrogens on the reactant side as well. Okay, so that's good. Let's look at the oxygen. So we got 4 oxygens here, and then 6 oxygens here, so that's a total of 10 oxygens, and we do have 10 oxygens there as well. Okay, So that one is good. Let's look at the charges. We have 2 minus here coming from the IO31 minus because it's 2 minus because there's a 2 in front of it. And then PB has a 2 plus charge, but there's 5 in front of it, so that's going to be 10 plus. So overall, that's going to be an 8 plus charge. And we want to make sure we have an 8 plus charge on the product side. And we do have an 8 plus charge on the product side because of the 8 H pluses. Okay, so this is going to be your balanced equation, all right, in terms of the acidic conditions. Now, how would you balance this in basic conditions? So there is only a couple of things you have to do to balance this in basic conditions. So first of all, go ahead and balance your equation in the acidic conditions, and then you have to add the appropriate number of OH minuses or the hydroxides on both sides to get rid of the H plus. Okay, so this is the equation that I have in balanced in the acidic condition. So let me just copy that down. Okay, so I've copied that down and put it down here. So let's try to balance that in the basic condition. So like I said, okay, we got to get rid of your protons, and I want to add the appropriate number of hydroxides on both sides. So since I have 8 H pluses there, I want to add 8 hydroxides on this side, and I want to add 8 hydroxides on the other side. So that's the only thing you have to do, and then see what it comes out to be. So when you add this 8 pluses and 8 hydroxide, that gets combined to make 8 water molecules. So that's the only changes you're going to have when you're going from the acidic to the basic. Now you can see there were already 4 hydrogens here, 4 water molecules here rather, and now you have 8 water molecules on the product side. So 4 of those will cancel out, leaving you behind with only 4 of them. So finally, your final reaction that's going to be balanced in the basic conditions is going to look like this. You got 8 hydroxides plus 2 IO31 minus plus 5 Pb2 plus, and then we got I2 5 PbO2, and then 4 water molecules. Okay, so then I got to make sure everything is balanced again just to double check. Okay, we got 2 I's on the reactant side, we have 2 I's on the product side, 5 leads on the reactant side, 5 leads on the product side. Got 8 hydrogens on the reactant side, we got 8 hydrogens on the product side, and 8 plus 6, that's going to be 14. So we got 8 oxygens here and 6 oxygens here, so that's a total of 14 oxygens on the reactant side. And this is going to be 10 oxygens here and 4 oxygens here, so that's again a 14 oxygens on the product side. So that one is also good. And then let's look at the charges. We have an 8 minus here, so 8 minus, and then we got 2 minus here, and then we got 10 plus here. So when you look at these reactant side, overall there is no charge, so it's a 0. And we'll look at the product side, there is no charge as well. So this is going to be your final balanced equation in the basic conditions. Alright, so this is how you're going to be balancing the equations in acidic and basic conditions. Make sure you have these steps memorized. If you skip any one of those steps, you may get your answer wrong. And then in terms of double checking your answers at the end, you can always make sure all your atoms are balanced and all your charges are balanced. Alright, so hopefully this video was helpful. If you have any questions or comments, leave them below.